So for reasons that are a little bit beyond the scope of this class, when we want to test if our correlation coefficient represents significant correlation between our two data sets, we can use an adjusted t-test procedure where our t-score, our test statistic in this case, depends on r and follows the formula r over 1 minus r squared over n minus 2, all under the radical. And you can think of this as being like our standard error type term. It's a little bit murkier here. That 1 minus r squared, we're going to see later, is actually a specific thing called the coefficient of non-determination. Don't worry about that right now. And this r is kind of like that distance from our central tendency, where we're kind of assuming no connection. So you might want to think about this even as r minus rho, where we always say that rho is equal to 0. And in particular, the degrees of freedom here have a slightly different value. In this context, we have n minus 2 degrees of freedom. If you want, you can think of that as being like we need to account for a degree of freedom coming from each of our two data sets in order to properly account for that variability. But in any case, when we have this setup in mind with this t-score and those degrees of freedom, the way we can test for the significance of correlation uses a fairly standard procedure up to a couple important adjustments. First, we state our hypotheses, where in this case we don't actually have a claim. I'll talk about that in a second. Then we specify the level of significance, identify the degrees of freedom, where here that is n minus 2, sample size minus 2. Find the critical values in rejection region, get the test statistic t, make a decision, and interpret the results. Where in this type of test, we don't really have a claim because we're not sort of operating under that assumption of whether or not there is correlation. We're just taking our options, either there is or there isn't, where we can look for the possibility of having no significant negative correlation versus having negative correlation, no positive correlation versus having positive correlation, or none versus some, where that relationship, again, it looks a little different than what we're used to, because we're kind of used to like that mu equals something specific or P1 equals P2. In this case, we're starting from whether or not rho is 0, and we're still sort of getting used to what rho is, so it's a bit murky. But just, we'll see it with some examples how exactly this works. And one other thing, at this point the book seems to kind of give up on using the p-value approach. I'm not super happy with that. Understand you could still do a p-value approach here, and I kind of will hide it in the background that we're doing stuff with p-values, but we're mostly going to focus on critical values here, though I will say I think we've had enough hypothesis tests. We've got more important things that we'll see with correlation coefficients and regression later in this chapter. This isn't a priority for me, but it is important that you see it at least once. It will be on the homework, it will be on quizzes, but as far as exams go, this is one that you don't need to focus on quite as much. Anyway, next, we're going to actually see this process, because you should see it at least once, if I'm going to put it in here, with that data that we're going to get kind of sick of by the end of this chapter, but it's good to have an example to stick with.